So, we're about to dive into a story about AI that honestly is pretty wild. It starts with a team of what you'd call expert AI agents, and it ends with a discovery that pretty much turns our entire understanding of AI memory completely on its head. And it all kicks off with this one single baffling quote.
Right? This quote from Nominex research is the central paradox we are going to solve today. I mean, how could giving an AI more information possibly make it perform worse? It just doesn't make sense. To get to the bottom of it, we have to go back to the mystery that started this whole thing.
Okay, so researchers at Nominex were running this team of highly specialized AI agents. Each one had its own specific job. But then one day, they're looking at the data, and they notice something, well, something very strange. Think about it this way. If you have a team with a marketing pro, a software architect, and a data scientist, you would never, ever expect them to get the exact same score on a performance review, would you? Of course not. But that's exactly what was happening here. Four completely different AI agents all landed on the exact same number. And that number was 0.92. Now, that's a really high score, which sounds great, but having four different specialists score identically, that wasn't a sign of success. It was a massive red flag. And it made them wonder what on earth they were actually measuring. So this led to the critical question. Was their team suddenly full of identical geniuses, or was their yardstick completely broken? Had their evaluation system just hit some kind of ceiling where it couldn't tell the difference between a pretty good agent and a truly brilliant, experienced one? They had to figure it out. So to test their own system, the researchers came up with this brilliantly simple and, let's be honest, kind of devious experiment. They decided to throw a complete rookie into the mix. They created what they called a blank agent. And this AI had total amnesia. I mean, zero memory of past projects, no clue about the team's previous decisions, no accumulated experience at all. It was basically a factory-fresh model sent in to do the same complex work as the seasoned pros.
So, what do you think happened? How could this AI with absolutely no institutional knowledge possibly compete with agents that have been learning and evolving for over 87 sessions?
0.92. The blank agent scored identically to the four experienced ones. This was the bombshell. It proved the scoring system was completely blind. It wasn't measuring expertise or wisdom at all. It was just measuring if a decent model could complete a task in a total vacuum, completely ignoring the team's shared history. And that discovery just blew the doors open on a much, much bigger problem. Okay, so the blank agent test proved they were measuring the wrong thing, and this led them to a really critical distinction in how we should think about AI performance. And it uncovered this hidden, really dangerous trap in how AI agents use context. This really gets to the heart of it. Their old system was just measuring task completion. Basically, can the AI spit out a single correct answer? But what they needed to measure was institutional coherence. Can the AI give a correct answer that is also consistent with the hundreds of decisions the team has already made? See, the first one is just basic model skill. The second one, that's true institutional memory. And when they started testing for this coherence, they found something genuinely dangerous: the partial context trap. This happens when you give an agent part of the truth, let's say one piece of a two-part decision. The agent sees it, assumes that's the whole story, and then gives you a confident, plausible-sounding, and completely wrong answer. And this is a huge flaw, because it means that in a lot of real-world systems, giving an AI more context could actually be making it less reliable. And on this test, all the models, from the most powerful to the most lightweight, failed spectacularly. They scored a 0.2. They weren't just wrong, they were confidently wrong. And that is the most dangerous kind of failure. Because to a human just looking at it, the answer seems totally fine. You'd never even know it was wrong unless you knew the entire history. So, if the complex, standard ways of giving AI a memory are this flawed and can even trick us, what's the answer? Well, it turns out to be something so simple it almost sounds like a joke. They called it poor man's memory, or PMM. And I want you to forget about fancy vector databases and complex retrieval pipelines. PMM is literally just a set of organized text files, things like decisions.md and lessons.md, all tracked in Git. It is the absolute simplest thing that could possibly work. Now, this approach has a totally different philosophy from the standard method. Most systems use what's called RAG, or Retrieval Augmented Generation. That's really just a fancy way of saying an algorithm finds what it thinks is relevant info and automatically crams it into the AI's context. The AI is a passive receiver. PMM is the complete opposite. It makes the agent an active participant in its own memory. The agent knows the files exist, and it gets to decide for itself when and how to go read them.
So, the big question is, does this ridiculously simple approach actually work? Well, the data isn't just convincing, it's a total game changer. This simple shift in thinking turned out to be wildly effective.
So check this out. This is the headline finding. The researchers broke down where the performance boost, the lift, actually came from. Only about 17% of it came from the context that was preloaded for the agent. But a staggering 83% came from autonomous retrieval. That's the agent deciding on its own to go and read the full memory files. So what the agents find for themselves is nearly 5 times more valuable than what we feed them. And this isn't some fluke that only works on the biggest, most expensive model. This performance lift is architectural. They tested it on 3 different tiers of models: Opus, Sonnet, and Haiku. And the smallest, cheapest model performed nearly as well as the flagship. The memory system itself is doing all the heavy lifting.
And get this, there's no complex prompting or fine-tuning needed here. All the researchers had to do was include a little note in the agent's system prompt telling it that these memory files exist and where to find them. Just that awareness alone was enough for the agent to start using them effectively. It's wild. Now, this is where the story gets even more fascinating, because once the agents had a reliable, transparent memory that they could actually control, they started behaving in ways the researchers never explicitly programmed them to. They started seeing these signs of, well, emergent team governance. For example, in one incident, a bunch of code templates got accidentally deleted. Instead of just grinding to a halt, the coordinator agent went and looked at its decisions.md file, which had the original specs. It then autonomously launched a new sprint, and the developer agents rebuilt the lost code from scratch based only on their shared auditable memory. This wasn't programmed in. It just happened. And this gets to the final beautiful piece of the puzzle. With a system like PMM, AI explainability isn't some extra feature you try to bolt on at the end. It's just built in from the start. When an agent makes a decision, you can trace its reasoning directly back to a specific line in a specific file, which traces back to a specific commit. The agent's entire thought process becomes a fully auditable Git log. This whole journey started with a broken metric and ended with a radically simple solution that not only fixed the problem, but unlocked these surprising new abilities. And it leaves us with a really provocative question to think about. If the solution to a problem as complex as AI memory is just simple, organized text files, what other impossibly hard problems in AI are we making way more complicated than they actually need to be?